Hello, everyone, and welcome to this Ask Me Anything. I have to say, I was really surprised by how actually sort of difficult a lot of these questions were. I've obviously been asked sleep questions and lots of them across the years, but these were really good questions. And what I'm going to do is I'm going to try and take as many as I can and maybe cap this at about, 40 minutes or so. I can well imagine you would not want to listen to me for more than about 15 minutes, but I'll go for about 40. I'll try and get through as many questions as I can. The way this will work is I will answer questions that have the highest order of likes. So I'll start with the top likes first and then kind of move down some of the questions. Some of the questions I will move through quickly because we're actually going to cover them in lecture, so there's no point in me kind of giving you that preface. Other questions I will skip, but I'll tell you why I have to skip them, because some of them sort of surround medical things and I'm not a medical doctor, so I won't be giving advice in that regard. And the second part of that in terms of business or housekeeping is I will try to read each question or at least summarize each question, and then I'll give my response. This prevents you from having to look at the questions online. Okay, so let's get started. The top question with 31 likes, I think at the point that we closed it, is probably one of the hardest questions. Why do some people need more hours of sleep than others? What factors determine how many hours of sleep someone needs? It's a great question because in a way we actually don't really have answers, although we kind of do. And here's the way I think is best to answer this question. That statement, why do some people need more hours than others? We actually don't know if that's true. What I mean is, firstly, someone else's subjective sense of how well they're doing and how well they're functioning with a lack of sleep is a miserable predictor of objectively what's actually happening in their brain and their body. And we'll come on to this time and time again in the course. In other words, you actually don't really know you're sleep deprived when you're sleep deprived. So some people may be sort of telling you, look, I'm fine, I can operate, I can function. And of course, they may be abusing high amounts of caffeine and actually other stimulant drugs too. A lot of people do this. I know there's study drugs out there, things like modafinil, and we'll speak a little bit about those as well. So I think the first response is we actually don't know if it's true that different people need more hours of sleep than others. But let's assume that the people that you're speaking about, you're saying, look, there's some people that I know who can be energized on 5 hours of sleep, whereas I need at least 8 hours of sleep and I don't understand it. Let's assume that they are mentally energetic, at least, that they appear to be sort of full of energy. That doesn't tell you about anything that's going on in their body. And so you assume just because their outward sort of demeanor and their behavior is one of high energy, that everything else is fine when they are on 5 hours of sleep, which I actually don't quite believe. But anyway, let's assume that that's true. My suspicion is that if you take those people who've been consistently sleeping, let's say 5 hours a night, and then we start to do some body assessments, you will start to realize how poorly they are surviving on 4 hours of sleep. So for example, if we looked at their blood sugar levels, we would expect that their blood sugar levels would be high. In fact, they would probably be borderline pre-diabetic. We could also look at their blood pressure, and my suspicion is that they would actually be erring on the side of being hypertensive, to have high blood pressure. We could also go much further and we could look at their DNA and their genes. We know that people who are sleeping that little actually have damaged DNA, specifically on their chromosomes. There are little caps that sit at the end of your chromosomes called telomeres. And think of them sort of like that cap at the end of a shoelace, and they stop the shoelace from sort of fraying and getting damaged. It's the same way with your chromosomes and these telomeres at the end. And what we see is that people who are insufficiently slept have actually shortened telomeres and damaged telomeres. So I think you need to be very careful in assuming just because someone's outward behavior looks like it's the same as yours, despite you sleeping 8 hours and then sleeping 5 hours, means that they remain just as healthy as you are on at 8 hours of sleep on their 5 hours. That may not be true. And I suspect if we assess them inside of the body, we would realize that that was not true. But there is something else in the literature that I think does speak to a little bit of this question, and it would be untruthful of me not to sort of describe it. There is a standard test of sleepiness that we'll speak about in the middle of the course, and essentially it assesses your attention. How well can you focus and pay attention? And it has become the gold standard measure of sort of sleep deprivation or insufficient sleep. So it measures one aspect of brain function, which is your concentration, essentially. Excuse me. And what people have found is that when you sleep deprive a bunch of people for one single night, so everyone gets the same dose of sleep deprivation, some of those people suffer very marked impairments on that test, but other people actually seem to be quite resilient. And that would almost suggest that maybe there are some people who can survive on less sleep, quote unquote, survive, than other people. And that would, I think, fit at one level with the comment that you made that perhaps those people who are resilient to sleep deprivation are the people who just need 5 hours of sleep. And you would be someone, when you need 8 hours of sleep, who would suffer a great deal if you were sleep deprived. Well, here's the rub, that in later years, they started to repeat those same experiments, but they started to test people not just on their concentration, but they looked at other brain measures. For example, they looked at how well they could learn or remember, or they looked at how well they were able to do decision making, or they looked at how well they could regulate their emotions and their moods. And what they found was that the people who seemed to be resilient to a lack of sleep on the measure of concentration were unfortunately very vulnerable to that same dose of sleep deprivation in other domains of brain function. So in other words, some people are resilient to sleep deprivation, but perhaps in only one domain of brain operation. And when you assess them on other areas of brain function, they actually show marked impairments. So somewhere along the way, everyone seems to suffer from insufficient sleep. And that's why I think the question still stands, why do some people need more hours of sleep than others? Well, I actually don't think it's true. Based on the data, I think we consistently find that everyone requires somewhere between, as an adult, 7 to 9 hours of sleep to protect against all of the impairments, both in the brain and the body as well. So I hope that makes some sense, but it's a great question and we're only just starting to sort of scratch the surface on it. Okay, question number two. Why might it be that the unsettling hallucinations experienced during sleep paralysis seem to be so similar from one person to the next? In other words, most people, when they suffer sleep paralysis, which I'll explain in a second, they tend to feel a presence in the room. It's usually a sort of a foreboding, dark figure, and you typically have this sort of fear response. Why might that be? Well, let's start with what sleep paralysis is. We mentioned this at the end in a question, actually, in lecture 2. But as we spoke about during that lecture, when we go into REM sleep, our brain paralyzes our body. And normally, as you wake up from a dream, from REM sleep, as you're gaining consciousness, the body times the release of the paralysis with perfection so that you just wake up and you can start to move and everything's fine. But occasionally the brain seems to fail in terms of releasing you from the paralysis as you're waking up. So you wake up to being locked in your body, and that is sleep paralysis, and it's quite unnerving. Why do people default to that experience, that when they're sort of trying to move, they've got their eyes closed, they just feel fear and they feel that there's a presence in the room? Well, when we go into that state, as I mentioned, the default emotion, for good reason, is fear. And in the modern age, the species that we do and we should perhaps fear most is not saber-toothed tigers anymore. It's actually other people. Now, I'm an optimist, and I'm trying to be very pessimistic about other human beings. But that's where the brain seems to default. And that seems to explain why it is that it's other people and perhaps other people that trigger a sense of fear in us. That is the common experience. And we'll go into that more in depth in perhaps one of the last lectures that we speak about in the course. Question number 3, and it's a great one. People tend to describe themselves as light versus heavy or deep sleepers. Are there correlations between these types of people and sort of other, let's say, personality traits or socioeconomic circumstances? And finally, what constitutes light and deep sleep? Well, that last part we actually discussed in the Q&A during the second lecture. And as I mentioned, the way that we typically define that as sleep researchers is by using stimuli that try to wake you up. And a good example of this would be sound. And we gradually increase the volume of the sound, the decibel, and we see at what point you wake up. And let's say that it's just a little bit of a beep and it starts to be increasingly loud. And we can look to see at what level does someone wake up. And then we can do the same experiment in someone else and see at what level do they wake up. And we can see if that differentiates a light sleeper from a deep sleeper. And that's typically the way that we do it. Within an individual, what defines light or deep sleep? Well, it's the same test, but we do that test during different stages. So we wait until they go into light non-REM sleep or deep non-REM sleep or rapid eye movement sleep. And we repeat that same experimental process and we see which of those stages of sleep is harder for you to wake someone out of. And that's what defines the depth in that sense of different stages of sleep. But what I haven't done is actually answer the question of perhaps what makes a light versus heavy sleeper. Well, one of the factors that we know defines a light from a deep or a heavy sleeper is actually those sleep spindles that we spoke about. Those sleep spindles that typically start to emerge during stage 2 non-REM sleep and continue during the rest of the deeper stages, stages 3 and 4 of non-REM sleep. And what we find is that those people who are light sleepers typically have less sleep spindles, whereas those people who are deep sleepers, they typically have more sleep spindles. And in fact, what you find is that when you play one of those little sound noises, the brain will often respond with a sleep spindle, almost as though one of the functions of sleep spindles is a guardian of your sleep, that it tries to push back against external noise and keep the sleeper protected in the sleep state. And that does seem to be one of the functions of sleep spindles. They have other functions, including learning and memory, and we'll speak to that later. But one of the traits that defines a light sleeper from a deep sleeper seems to be the number of sleep spindles that they have. Those people who have more sleep spindles seem to have a higher tolerance in terms of noise and disruption of their sleep. They seem to be able to resist that disruption more. But let's answer sort of the second part of the question, which is, are there correlations between these sleep types and other traits, personality traits or socioeconomic circumstances, etc.? And yes, there are. You can have even someone, let's say, who is a heavy sleeper by default, by their trait, but you can move them towards becoming a lighter sleeper on the basis of, for example, stress and specifically anxiety. And what we see is that when people are often stressed, they seem to be more vulnerable to being woken up. And we also know that anxious people in general typically have less restful sleep and are easier themselves to be woken up. Is that due to their sleep spindles? We actually don't quite know, but there is something else about people who, when they become quite anxious and they suffer from insomnia, they typically have faster brainwave activity even when they're in deep sleep. It's almost as though that faster frequency brainwave activity, which is common normally during wakefulness, seems to sit on top of deep sleep. And it seems to sort of keep you in this slightly hyper-aware state. Even though you're asleep, you're sort of just sort of, above that threshold of non-consciousness. There's somewhere in between that you sit, and that's why you're a lighter sleeper. A more subtle version of that is probably what many of you experience, which is when you go and sleep in an unfamiliar environment, such as a hotel. What we know is that when people do that, they typically show higher vulnerability again for being woken up. Why is that? Well, it's because it's an unfamiliar environment. And from our age-old sort of evolutionary genetics, that typically means that we should be a little bit more on guard. We don't know how safe that location is. In other words, there's a threat signal that comes with unfamiliarity. And typically, not always, but typically people don't sleep as well, or they at least sleep lighter, quote unquote, as it were. And we'll speak more about that hotel effect later in the course. And question number 4, and it's a question I get asked quite a lot. Are fitness trackers such as Fitbit really all that useful or accurate in essentially tracking someone's sleep? Kind of yes and no is the answer. Right now, the fitness trackers out there are all pretty much of a muchness. And what I mean by that is their accuracy is all quite similar. Now, they may be inaccurate in different ways, but overall, those devices typically have about a 65 to 70% accuracy in defining wakefulness from light non-REM sleep, from deep non-REM sleep, from REM sleep. And they're the 4 things that those sleep trackers typically will separate out. What I would say is that those fitness trackers are probably not bad at quantifying your overall total amount of sleep. I think that they probably get that more accurate, probably in the realm of about 80 to 85% accuracy. But when it comes to trying to separate out non-REM from REM, and furthermore, light non-REM from deep non-REM, that's really where they have the hard time, and that's really where they fail. What I would say is that those fitness trackers seem to be consistently inaccurate. For the most part. What do I mean by that? Well, let's say that overall, their general ability to define truly, what is non-REM sleep and light non-REM and deep non-REM is not great within an individual, but that inaccuracy remains constant. So when you start to see changes from your ongoing sort of habitual sleep patterns measured with those devices, then those changes may actually be real. Because once it's got sort of its baseline of inaccuracy, in terms of hardware and software, it essentially remains the same thing. So you're locked into that inaccuracy, and therefore any changes from one night to the next thereafter are actually perhaps real changes that are happening not because the device or the software is changing. It typically doesn't. It's perhaps because your sleep is changing. So I guess what I'm saying is I wouldn't believe the overall absolute numbers, but what I perhaps would be more inclined to believe is the relative change around those inaccurate absolute numbers, if that makes sense. The other thing to sort of consider is the form factor. I think what we see in the industry is that, anything that you have to put on your head, for example, people don't typically wear that for very long. The adoption rate, the stickiness of those types of pieces of hardware is very low. After about a month, people just stop using them frequently. Why would you? Same with Fitbit. A lot of people don't like the wristwatch device and the sensation of it when they're sleeping. And that's no big surprise. If you think about it, when we go to bed, we take things off. We don't put things on. And that's why it's quite foreign to us to do those types of things. So I think the form factor is important. Just for transparency, I wear an Oura Ring. I don't have any affiliation with any of the companies at present, so full disclaimer. I see that it's inaccurate, but I do like the form factor just because, a ring feels less intrusive, and I never really enjoyed the sensation of the Fitbit on my wrist. And I've tried just about every sleep device that's out there, and I would say that the Oura, in terms of a form factor, is probably the least bad sleep tracker out there. The final question that or sort of embedded there is it really useful? Not just is it accurate, but is it useful? I also think the answer here is largely yes, but sometimes for some people, no. What I mean by that is In medicine, we typically say what gets measured gets managed. And sleep is a tricky one. We tend obviously not to be conscious, and so we're not really aware of what this thing called our own personal sleep actually is or looks like. So for example, if I asked you, how did you sleep last night? You could probably tell me with some degree. But if I asked you, how did you sleep last Tuesday? You don't remember. You can't tell me. But your sleep tracker can. So it can keep a history and it can show you some interesting profiles and patterns. And it can help you perhaps manage that. Are you doing what we call social jet lag, where you're going to bed late and sleeping in late at the weekend, and then you drag yourself back for classes during the week and you kind of keep shifting back and forth? That's what we call social jet lag, and that's torture for your biology. Can you see that on a weekly basis? Well, that's good evidence to suggest that you need to change your behavior and improve your regularity of sleep. So I like them for that sense of trying to help manage your sleep patterns and your sleep behavior. The reason it doesn't work for all people is that sometimes some people get a little bit stressed out by seeing that. And there is actually a new sleep disorder that's starting to emerge, or people want to try and suggest that it's emerging, and it's called orthosomnia. So somnia, obviously, in terms of sleep, where you've heard it sort of sounds like insomnia. Ortho actually comes from the medical term, you've probably heard of it in orthopedics, which actually means straightening of bones. Well, this is not straightening of bones, this is trying to get your sleep straight. That's where it comes from, orthosomnia. And some people get quite anxious that their sleep isn't perfect, or it's sort of changing a little bit too much from one night to the next, and they get very worried. And that creates anxiety around sleep, and then they start to sleep worse as a consequence. So there is that caveat. I think it's a small percentage of the population that suffer that. But hopefully I've answered both of your questions. Is it accurate? Well, I've told you about accuracy, and we're not there yet. I think we'll probably get there somewhere in the future. In truth, I think probably the mattress is going to be the ultimate best sleep tracker out there for a number of reasons. Is it useful? I think it is for most people, as long as you understand the inaccuracy of the system. And then for those who find it a little bit stressful, I think it may actually not be useful. Question number 5, how much does posture matter when we sleep? I've heard from, in parentheses, perhaps less than reputable sources, that side sleeping helps with breathing and even cleansing the brain of something called beta amyloid, which is a toxic protein associated with Alzheimer's disease. Is this valid? Does position really affect anything? How can you wake up with sort of better posture and less pain? Well, there's actually surprisingly little data on this, and there's somewhat differing opinions. Let me just take a step back, though. The most popular of all three sleeping positions, and obviously the three sleeping positions are you sleep on your back, you sleep on your front, or you sleep on your side. And the side is typically in this sort of more fetal-like position. The side is what seems to be most common. About 45% of the people typically sleep on their side in that sort of fetal curled up manner. That seems to be more common in women than it is in men, just as an FYI, whatever that means, we don't quite know. I would say that there's probably two pieces of information that I would like to mention regarding position that are scientifically meaningful and speak to this question. The first is, if you are someone who snores, or you've been told that you snore, or you suspect that you snore, and by the way, if you think that you snore, just go to the Android or the Apple store and search for something called Snore Lab. So it's Snore Lab, all one word. And it's a free app, and you can download it, and then you turn it on before you go to sleep at night, and it will listen and record your breathing throughout the night, and it can show you how severe, if at all, your snoring actually is, and it grades it from very minor to, I think it calls it epic. And it's really interesting, just because, again, this is something that you're not aware of. You typically don't listen to yourself when you're asleep. Why would you? Unless you're really narcissistic. But this actually helps you understand, are you a snorer? And you may be unaware of this, or you may be unaware of how severe. And the amazing part of this app is that you can go throughout any part of the night and tap on it, let's say when you see a really strong kind of snoring signal and you can listen to yourself snoring, and it's quite concerning and alarming. What has this got to do with position? Well, if you are someone who snores, then being on your back is not a good idea, because when you lie on your back, typically your airway is more likely to collapse. Now, when you are snoring, you may be suffering from a condition called sleep apnea, which we actually won't get to in the course. And one of the most common forms of sleep apnea is called obstructive sleep apnea, and that's where your airway... Next question, is it true that everyone technically dreams, but they don't always remember their dreams? And then the question goes on to say, what is the relationship between memory and the unconscious that sort of may underlie this? And more concretely, is there any chemical or biological evidence that may help explain if this is true or not? And then the last part of the question was sort of really relating to why on earth are dreams so real? And they feel incredibly real when they're happening and very intense, and sometimes they can be very upsetting. Lots to get into here, and I'll probably just focus on the front end of this question. The answer is yes, everybody dreams. The difference is that not everyone remembers their dreams. So let's say that if you're one of those people who say, look, I really don't think I don't dream very often. If I bring you into the sleep center and we start measuring your sleep, and then we let you go into rapid eye movement sleep, which is the stage from which you principally dream, and then we wake you up and ask you for a dream report, you will reliably give me a dream report. And we've sort of done these studies way back where we had people who claimed that they definitely did not dream, and then we woke them up from REM sleep and immediately asked them, what was going on. And they're like, this is amazing. It's the first time. Something about this laboratory. First time I'm ever dreaming. And it's not true. It's just that if you're not asked what's going on, or you're not typically woken up out of REM sleep deliberately by someone else or something else, then you often don't remember your dreams. There's something about the inability to commit dreams to memory that may fail some people. And as a consequence, you actually don't think that you are dreaming. Now, by the way, I've got a bit of a problem with the logic that I just described, which is that people may fail to kind of memorize their dreams. And that's the problem, that they don't remember their dreams because they're not making memories of them as they sort of, when they wake up, the memory button isn't sort of hit, as it were. I actually don't know if that's true. And I've got a strange hypothesis that at some point I'll try and test, which is that, in fact, we don't forget many of our dreams. Maybe in the extreme, we don't forget any of the dreams that we have at all. We remember all of our dreams. The issue is that we just don't have access to those memories. In other words, the issue isn't even that we don't memorize what we've been dreaming. The problem is that we lose the IP address to those memories when we wake up. And I think many of the reason that I have this belief, I've had those experiences where I wake up and I think, I was definitely dreaming, and I just cannot remember what that dream was. And I just let it go. And then several days later, I could be walking down the street and I'll see some sign in a shop. And all of a sudden, it just acts as a cue, a trigger that unlocks unwittingly this dream that I'd had several nights before. What that tells me is something about, as a neuroscientist of memory, it tells me something important. It tells me that the memory was there and it existed. I just couldn't recall it. In other words, the memory was available, but not accessible. So it's almost like a file. The file is there on your computer, on your hard drive, but you can't find it, or you can't double click it. It sort of won't access or open. So there seems to be, I think, something around there. At some point, I'll test that hypothesis. I'm sure it'll be wrong. But I'm drifting. Walker, focus on the question. So you asked, does everyone technically dream? And I said, yes, they do. That's not true either. There is a very rare group that we've discovered of neurological patients that have specific damage to a small part of their frontal lobe that sits directly above their eyes. And when you bring them into the laboratory, and again, they say, look, I just don't dream. I never remember my dreams, and we say, okay, yeah, sure, come into the lab. We wake them up during REM sleep and we say, tell us what was happening, what was going through your mind. And they don't report anything. And it literally is. There's no way that we can extract a dream from them. It just doesn't seem to be there. And as I mentioned, in subsequent studies, we've been able to look at the brain scans and see that, in fact, there's a part of the deep frontal lobe, and particularly what we call the white matter. You've heard of gray matter in the brain. Well, the white matter in the brain are the big fiber tracts, the sort of the informational highways within the brain, where the messages throughout the brain are actually passed on and travel. They have a little bit of damage to that white matter in the frontal lobe that suggests, at least on that basis, that there's something about the functioning of your frontal lobe that is critical to either dreaming or at least making memories of the dreams themselves. Finally, the question was, why are dreams so real? Why do they feel so real? Well, this is due to the remarkable virtual reality of reactivation of so much of your brain when you dream. And this perhaps shouldn't be so surprising. You know, just as you can close your eyes and consciously sort of relive a very powerful memory, perhaps a very powerful emotional memory with just your imagination, and it feels very real. Well, the same seems to be true in REM sleep, perhaps even more so. And I will actually describe the neuroanatomy, which is, please don't get worried about that term, but basically how your brain lights up essentially when you go into REM sleep, and how that pattern of brain activity actually will help us understand why dreams feel so incredibly real and also so emotional. Okay, question 7 and 8, because 7 is going to be a short response, then I'll move straight on to 8. Question 7, we spoke about this a little bit in class in lecture 2. Why do some people talk in their sleep? Well, sleepwalking, sleep talking, sleep eating, there's even sleep texting that has now been accepted. Yes, that seems to be true. They are all conditions that are called parasomnias. Para meaning sort of around, and somnus meaning sleep. So these are things that happen around sleep. Why do I say around sleep, not during sleep? Because that's when they seem to happen. Well, we'll actually have a whole lecture on parasomnias and sleepwalking and sleep talking. They come from not rapid eye movement sleep, as you would imagine. Perhaps you would think it's people dreaming and they're speaking about what's going on in their dreams. That's not actually true. They happen from deep non-REM sleep, and we'll speak all about that in a later lecture, so I won't preempt that. Let me move on to question number 8, though. How effective are dreams in processing trauma? Are they more effective than emotional processing in the conscious mind? Firstly, dreams and REM sleep in particular seem to be effective. There's a lot of work going on right now regarding the quintessential trauma condition, which is called post-traumatic stress disorder, or PTSD. And we've been lucky to be a part of this research field. We do work in this area. And there are indeed actually treatments, sleep treatments, particularly around REM sleep, including dreaming. These programs that are underway in the Veterans Administration hospitals right now, trying to help war veterans who suffer from PTSD. And we're trying to use the science and our knowledge around dreaming, particularly about how REM sleep may actually help with processing trauma and dissipating the severity and the sensitivity of that trauma. Why does REM sleep specifically seem to help? Why does it provide some type of sort of nocturnal soothing balm? Well, later in the course, we'll have almost an entire half of the lecture dedicated to this topic as to why it is that REM sleep specifically seems to be so biologically capable of helping us deal with trauma. The second part of your question was actually a very clever and astute one too, though. Our dreams, in other words, is our sleeping process of trauma resolution more effective than our waking processing of emotions and trauma in terms of the conscious mind? I don't think anyone in truth has tried to sort of put wake and sleep head to head in some Coke Pepsi challenge for trauma. What we certainly know is that both dream sleep and waking therapy are helpful and can be effective in helping people move past and deal with that trauma. So right now, I don't think there's any evidence to suggest that one is more powerful than the other. Certainly, there are a lot more treatments out there that are designed to be given when you're awake and function when you're awake, but there is also a strongly emerging set of research that I will talk to you all about in lecture regarding the benefits of sleep, and specifically REM sleep. So we will speak about that probably in the middle to the later part of the course. So next question is number 9, and it is, how can I help my mum sleep better? She's in her mid-50s, she suffers from insomnia, and the question goes on to say that she's tried just about everything so far, from sort of going to bed and waking up at the same time, sleeping pills, exercise, yoga, meditation, seeking advice from doctors, but nothing really seems to be working. Well, firstly, I'm just so sorry. I'm so sorry that your mother is suffering in this way. And I'm sorry that she hasn't found the help or the treatment that is beneficial or helpful for her. The first thing to note, and this will probably come up time and time again in class, is that I'm not an MD. I'm not a medical doctor. And therefore, I'm not able to give specific medical advice on anyone's condition. What I would say is that if anyone, the recommendation right now that we have for anyone suffering from grave sleep problems is to seek out a treatment called cognitive behavioral therapy for insomnia, or CBTI. This is where you work with a trained therapist, and we'll actually speak a little bit about this in one of our last lectures of the course. And it really tries to address the whole picture. It tries to look through all of the different things that are preventing that individual from sleeping, and then creates a specific tailored approach to that individual to help them start sleeping better. CBTI is just as effective as sleeping pills in the short term, but what's beneficial is that when you stop working with that therapist, the benefits continue, and those studies, those follow-up studies, have shown that the benefits remain for several years afterwards, unlike sleeping pills, where, as we will discuss, when you stop using them, you go right back to the severe insomnia that you were having before, if not worse, something called rebound insomnia. So what I would recommend for anyone in this position, and perhaps your mum as well, is you can go to a website called sleepeducation.org, and in the search bar, just type find a sleep center. And perhaps we can even try and put this, or I think it's actually find a facility. That's what you should type in that search bar. So go to sleepeducation.org. In the search bar, type find a facility. And I think it's the first link. We'll try and send out this link if I remember, and someone sort of shout out if I forget to do this. And there what you can do is you can insert your zip code, and you can search for all of the accredited sleep centers. Centers that have been accredited by the American Academy of Sleep Medicine, which is the board that certifies these people. And you can find locations around your particular living place that have been approved for good CBTI treatment. So I hope that helps a little bit. And as I mentioned, I'm sorry I can't give very specific medical advice to any one person or any one condition, but hopefully that general advice will help your mum, or at least help others along the way. Okay, so I think we're almost out of time, so I will maybe take one more question. Actually, do you know what? This question is an important one, but the next one is also really interesting too. Okay, I need to be quick. I need to be more efficient. So I'm going to try and I'll do 2 more questions here. So question number 10 is, what are the long-term effects of stimulant drugs used to treat ADHD? Things like Ritalin or Adderall, for example, what do the impacts of those drugs have on sleep and the sleep of people who have ADHD, and also any other people who use them sort of quote unquote as study drugs or recreational drugs? Ritalin and Adderall are both stimulant drugs, as you mentioned, that are used to treat ADHD. Ritalin and Adderall, they both have sort of a similar historical chemical basis, which is that they're based on methamphetamine, and Ritalin is essentially methamphetamine salt, and Adderall is a sort of a chemical derivative of that structure. And what we know, of course, is that amphetamine keeps people awake. It keeps people awake for several days. But let me take a first step back. What we know is that people with ADHD don't seem to sleep very well. They typically have disrupted sleep. They suffer from aspects of insomnia. They either find it difficult to fall asleep or difficult to stay asleep. They take longer to fall asleep, and their sleep patterns are usually fragmented. They usually have more awakenings throughout the night. And it's for these reasons that you can then imagine giving these individuals a stimulant drug has in the community, in the sleep field, proved to be somewhat controversial, because if they're not getting sufficient sleep, and there's some evidence now that insufficient sleep may be contributing to the severity of the disorder, and yet the pharmacological treatment for that disorder is only making that sleep worse, then how should we think about that? What should we do? And there are currently no guidelines or recommendations. Again, I'm not trying to play doctor here or pretend to be a doctor. I'm just trying to describe the science more generally. There have been some studies that have looked at individuals when they've been on versus off either Ritalin or Adderall, both these stimulant drugs. And these are individuals who have a diagnosis of ADHD. And what you typically see in those kids, and this is self-reported by the parents because the children don't often have the ability to sort of describe their sleep, but when they are on those drugs, there is some data that parents say that the child typically shows greater issues around insomnia. And furthermore, there's some interesting data that shows that the severity of that insomnia in those ADHD people being treated with those drugs scales as a function of dose. So the higher the dose, the worse that insomnia seems to be. There's also some evidence that those drugs seem to reduce rapid eye movement sleep, whilst non-rapid eye movement sleep has not yet been shown to decrease, at least not statistically significantly. I should also note, however, that there have been several small studies that report no significant impact on self-reported sleep in kids that have been treated. So I think the evidence is still unclear right now. I just don't think there is anywhere near enough good science that's been done on this topic in these populations. But what we certainly know is that those drugs in healthy adults will disrupt sleep and typically prevent you from sleeping. So I think the summary is this: the field doesn't seem to see those stimulant drugs as being especially helpful for the sleep of people with ADHD, but they're not confident yet because of the lack of data to actually make any strong medical recommendations on the guidelines regarding those treatments. Some people right now are thinking more about, rather than do you dose or do you not dose with those drugs, it's about the timing of that dose and the magnitude of that dose. So rather than giving the dose in the middle of the day or in the afternoon, they've been thinking about giving the dose in the morning and then seeing if with the half-life of the drug, the effects of that drug start to decline in the evening, allowing sleep to be perhaps more normalistic. That's some of the thinking around it as well. But right now, not enough data. Okay, so question number 11. I know that giraffes need close to only 2 hours of sleep a night, which makes me wonder if the amount of sleep an organism needs is based on the amount of their brain capacity or the work that that brain needs to do, or instead is it more based on time necessary to sort of clear out the pathways using that glymphatic system that we spoke about? Gosh, this is a great question, and it turned out to be one of the most difficult and, for the most part, unanswered questions in all of sleep research. So the history was early on, we actually thought, okay, it's probably just a very simple thing, such as your predator versus prey status. In other words, how high up are you on the sort of in the food chain, as it were? And so the idea would be those species that were preyed upon a great deal, who were very low on the food chain, would not sleep very much because they needed to remain vigilant and be awake for those threats. And that turned out not to be true. There was a little bit of a prediction sort of strength. In other words, if you looked at your prey versus predatory status and you correlated that with how much your sleep need was, and at this stage, we'd been able to map the average sleep in all of the different species. So we had those numbers. And when we aligned it with the predator versus prey status, it didn't line up very well. It wasn't a perfect fit. So that left us very sort of unsatisfied. Next, we thought, well, maybe it was down to energy balance. So for example, is it about the amount of energy that the species uses or something related, such as their metabolic rate? And that didn't seem to do very well. Again, it had some vague predictive relationship, but it wasn't very strong. And it turns out that it's not one simple thing. What we've discovered is that it seems to be a complex collection of different things. And at present, the best Da Vinci code that we have that seems to accurately predict how much sleep a species needs is a hybrid of many of these factors. So the first seems to be dietary type. Whether you're an omnivore, herbivore, or carnivore, that has a predictive relationship. Second actually is prey versus predatory status, where you sit on the food chain or the food ladder, as it were. You add that and things improve. The third component is whether you're a social species, and furthermore, what is the size of that social network, meaning it in the non-Facebook way of the term. The fourth is actually metabolic rate too. That still holds some value. And the fifth is actually the complexity of your nervous system. And when you add all of these sort of 5 factors together, the fit of the relationship seems to improve significantly. So there is a complex combination of things that ultimately seem to determine how much sleep a species needs. By the way, I'm very specific with my words there. It's not about how much sleep a species can actually get. It's how much they need that we understand it. And that's a very different way of thinking about it. What does that mean? Why is it such a complex equation that predicts sleep need? Well, to me, I actually think that it speaks to the fact of sleep having been shaped by many different forces along the evolutionary pathway. In other words, your sleep need has been determined by a delicate balancing act between lots of different competing factors needing sleep to be in place. So that's our current understanding of exactly why there is such large variability from one species to the next in terms of sleep need. Okay, and with that, I will close. I suspect many of you have already gone offline, and for any one person, and there may just be 1 or 2 left listening to this, thanks so much for sticking with it, firstly. Second, if you've found this useful, please let us know. Send me an email or tell your GSIs, better still. And we will learn more about whether this is a useful format or not. We've got too many important lectures to get through, so we won't be substituting any more for them. But I think there's so many unanswered questions left that if there is an appetite for more of these, then I will do more of them and I'll just post them. And it's up to you if you want to listen. By the way, none of this information is going to be on the exam. It's just purely for your edification. And again, if we do more podcasts, it doesn't mean podcasts, AMAs, it doesn't mean that you will do, you'll have to study more. Okay, and with that, I wish you good sleep and thanks very much.